What's up guys, welcome back. So today we're going to be looking at sketching sine curves and how to deal with a few different variations if they want you to move it left and right or up and down. Okay, so let's get into it. All right, so the first thing we're going to sketch is y is equal to sine x. And y is equal to sine x is pretty straightforward and something you kind of need to remember. It has this shape here and it goes from 1 to -1. And you can kind of think of these as your quadrants, so pi on 4, or sorry, pi on 2, pi, 3 pi on 2, and 2 pi. Okay, so they're your points that you need to be aware of. Now, I'm going to teach you a method on how to sketch these harder ones in a tick, but just notice that this, what it's going up by, we're going to call this our x scale, okay? This is your amplitude, so how up and down, or how high and low it goes. And your period is basically how often it does one revolution. So this is a period of 2 pi. Okay, so it basically comes one revolution in at 2 pi. Okay, so this is y is equal to sine 3x. Now, like I mentioned before, you have these couple things. You got your amplitude, which is, I'll just say is A. You got your period, and we're gonna have this thing called your x scale, which I'll explain in a sec. So your amplitude, your period, and your x scale. So the sine curve takes this kind of general form, y is equal to a sine bracket b bracket x minus c close bracket plus d. Okay, now I'll explain these one at a time, but your a here basically is your amplitude. So the thing at the front will tell you how high and low it goes. So in our case, if it has no number, it's going to be 1. So I'll just pop a 1 there. Okay, your period, so how often it comes back around and does that shape, is given by this formula, 2 pi over b. So in this case, where's our b? Our b is out the front of x, so it's going to be 2 pi on 3. All right, and then our last thing, our x scale, is our period divided by 4. So that's what we're going to label our x-axis. So our period is 2 pi on 3, and we're dividing that by 4. So when you have a fraction divided by this number, you'll have 2 pi on 3 times by a quarter. Those 2 and 4 cancel out, so you'll have pi on 6. So basically, we're going to make our graph go up by pi on 6 units. So first things first, let's draw up our graph. Starting at 0, we said our x scale is going to be pi on 6, and we need to get it to 2 pi. So converting this 2 pi into the denominator of 6 will be 12 pi on 6. Okay, so that's our stopping point. All right, so let's label it. So you got 0, try to do it evenly, pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6, and so on. So it will go to the end. Okay, so once you've labeled your x scale and your x-axis, we'll just pop in our amplitude, so 1 and -1. Okay, so it's kind of a lot of work to start off with, but it makes it really simple once we've got like the foundation ready. So all we need to do is, right, we know that sine looks like this, okay, for a positive one, which is what we got here. So for each one of these x scales, we're going to put a x where it would be. So for example, right, I know it starts at 0 and then it goes up. So it goes up to 1, and then comes back down and back to -1, and then returns to the x-axis. So tracing that out, you'll have that first. Now that hits at 4 pi on 6. So notice that hits at 4 pi on 6. Well, that's the same as 2 pi on 3. So that's correct. Okay, so it does one revolution by the time it hits 2 pi on 3 or 4 pi on 6. So now you just continue till you get all the way to 12 pi on 6. So here we go. Okay, and there you are done. So as you can see, you have 3 revolutions between 0 and 2 pi, and that 3 refers to the 3 inside. All right, here's the next example. Y is equal to 5 sine 2x. So you'll get used to writing this out, but this is the general form as we said before. Okay, so that's it there. So first of all, let's find out amplitude. Amplitude is going to be 5, so the number at the front. Our period is 2 pi over b. So in this case, our b is 2. So that's going to be 2 pi on 2, so pi. Our x scale is going to be period over 4. So it's always 4 for the sine curve. So period here is pi, as we just found before, divided by 4, so pi on 4. Okay, now for now, we don't have to worry about the c and the d because there is no kind of number for that value, but we'll deal with it later. So like before, draw in your axis. Okay. All right, now we're going to just put in the x scale first. So we've got 0, pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4. Okay, so that's pi. So we've got to go all the way to 8 to get to 2 pi. All right, so that's your x scale done. Put in your amplitude. So what's your amplitude? It is 5. So instead of having 1 and -1, it's going to be 5 and -5. Okay, so now let's just put in the x's. So once again, it's positive sign, so it's going to look something like this. There we go. That's the first one there. Done. Yeah. Okay, so as you can see, there should always be a x, like a cross or a dot, where your x scale is. That's the whole point of the x scale. All right, let's have a look at this example here. Y is equal to sine x on 2 plus 2. So a bit different here. First thing I'm going to do is just rewrite the general form we said before. Okay, so let's start with our amplitude. So our amplitude here is going to be 1, because that's the number out the front of sine. Now b here, or our period I should say before, our period is 2 pi divided by b. Now in this case b, right, b is the number outside of x. It's separate to x, okay, so there's just a number by itself. So in this case, you're going to see it's actually 1 over 2, because that's the number next to x. So this is 2 pi over a half. 2 pi divided by a half is 2 pi times 2, so that's 4 pi. Okay, that's our period. Okay, our x scale is going to be period divided by 4. So in this case, it's 4 pi over 4, so just pi. Okay, now so far we've only had these 3 things. We haven't dealt with the letters C and D yet, and we haven't done that because they haven't existed. In this case, let's actually do it now. So the things that represent C and D are what we call the phase shift and the D here represents the vertical translation. Okay, so VT. Now the phase shift here is just this bit. Okay, this bit in brackets. Make that equal 0. So x minus c equals 0. And all that tells us is where the graph starts. It tells us where the graph starts. Okay, so in this case, it's going to be x on 2 equals 0, so x is equal to 0. So your graph starts at x equals 0. So not much to worry about there. And your vertical translation is just the last number here. So where we're kind of shifting the graph up and down. So in this case, it is plus 2. All right, so let's bring this all together. Okay, so here is our graph. I'm going to put in your amplitude of 1 and -1 first. Now, I'm going to actually ignore this vertical translation for now, and we're just going to sketch it as though it was y is equal to sine x on 2. So you'll have pi, which is your x scale, or 0, and then also 2 pi. Put in your x's, so it goes up and down. Oh, sorry, that should go at 2 pi, shouldn't it? Okay, so your graph should look something like this. But we haven't taken into account the +2. So what happens here is this graph actually gets shifted up 2 units. So instead of starting at 0, it starts at 2 and does this. Okay, it starts at 2 and does that. So what I'm going to do is, just to make my life a little bit easier, I'm going to actually just, instead of moving everything up, I'm just going to shift this thing, our x-axis, I'm just going to shift it down 2 units. So instead of having it at here, I'm just going to get rid of this -1 for a second. I'm going to draw it down here. Just replace the pi and the 2 pi. So that's 0 now. Okay, just relabeling it. I'm going to get rid of this thing here. My original x-axis. And my starting point, my new starting point will be 2. Okay? My new starting point will be 2. And because it has an amplitude of 1, it means it's going to go up. Like the highest point is going to be like +1 from where you started. So in this case, instead of having 1 here, I'm going to have 3. And that's it. All right, let's have a look at this one. Y is equal to sine bracket x plus pi on 2. So now we're going to have to deal with this phase shift business. So amplitude is the number up front. So here is 1. Our period, so 2 pi over b. Now, as you can see, the number, okay, so the number out the front here is actually 1 outside the bracket. So it's just going to be 2 pi over 1, which is 2 pi. Our x scale is period over 4, so 2 pi over 4. That's pi on 2, as per normal. Now our phase shift, remember, is this whole bracket equals 0. So we go x plus pi on 2 equals 0. So x is equal to minus pi on 2. So that tells us where it starts. And lastly, your vertical translation here is 0. So when you do these ones and we're still in the domain of 0 to 2 pi, we're just going to draw it outside of that and we'll clean it up at the end. So because I know I'm starting at x is equal to minus pi on 2, your phase shift, so this is where you start, x is equal to minus pi on 2, I'm going to start back here. Now in this example, it works nicely because your x scale and your phase shift have the same denominator, so there's no kind of conversion you need to do. You just need to go up by pi on 2 for your x scale, like this. All right, so here we go. So pi on 2 plus pi on 2 here is 0, plus another pi on 2, 2 pi on 2, 3 pi on 2, and lastly 4 pi on 2. Okay. Now sine here is positive, so it just looks like this. Okay, it's the same as normal, but we're going to start at x is equal to minus pi on 2. So the starting point is here. I forgot my amplitude, which is 1 and minus 1. So I start here, I go up, down, down again, and then back up. So just to show you this first bit, before I put in that last x, it'll look like this. As you can see, it's been shifted to the left. And then the next point here will be up, back here. Okay, because it's starting to repeat again. So that's the curve y is equal to sine x plus pi on 2. But I don't have this bit here. So I just need to delete that. Okay, and then I'm done. All right, guys, last example today. So sketch y is equal to 2 sine 2x minus pi. A little bit different this time. So before I even start, I'm going to do a little thing where I'm actually going to factorize this bit in here. Okay, because I want that number on the outside. I want that b on the outside. So y is equal to 2 sine. Now, you might look at this and you go, there's no common factors. How can I factorize it? But it doesn't matter because I can take out the 2 and I just ask myself, 2 times what is 2x? Okay, now it's obviously x. This will be a minus in the middle. 2 times what is going to give me pi? 2 times what is going to give me pi? Well, that's actually going to be pi on 2. Okay, so take some time to really think about that. 2 times pi on 2 is going to give me pi. Right, now once you've rearranged it, now we can go straight into our kind of algorithm. So amplitude here is 2. Our period is 2 pi over b. Now b here is that 2 in there, so 2 pi on 2, which is pi. our x scale is pi on 4. So that's, period on 4, which is pi on 4. Our phase shift, okay, so our phase shift is just that bit there. No need with the 2, it's just this bit in here. So our phase shift is x minus pi on 2 is equal to 0. X is equal to pi on 2. And then our vertical translation is 0. So we don't have to worry about that. All right, so once again, draw up your axis. Two minus 2. Okay, so here's a little bit different now because your x scale, right, what it's got to go up on the x-axis, has a different denominator to your phase shift, or where you need to start. So I'm just going to change the phase shift so it has a denominator of 4. And that tells me my starting point should be 2 pi on 4. Okay, so once again, let's just start with a 0 and just put your numbers in. So you got pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4, 8 pi on 4. All right, so we're starting at the phase shift. We're starting at 2 pi on 4, and sine graph looks like this, okay? So we're starting at 2 pi on 4, so it should be here. That's your first cross. Then it goes up, comes back down, comes down again, and then back up. So one revolution is here. Okay, just repeat on the right-hand side. So from the middle, it goes up and then back down. So now you got that bit there. So the only bit you need to take into account is this kind of region here. You've only got one more x scale and the 0, and you know it's coming back down. So it has to be here and here. And there you have it. All right, so I hope that helped. Yeah, this is a really good technique once you get it down pat, because you don't really have to think too much when you're sketching these curves that can be confusing at times. All right, so I hope that helped. If you have any comments, let me know down below. Otherwise, I'll see you in the next one. Peace.